Okay, now let us see at the earliest start resource load chart here. Okay, we load everything in this resource load chart. Okay, we have ID number, resource, column, duration, earliest start, latest finish, slack, number of days, and also total number of resources planned for here. Okay, we can see that we still have slacks, 2 day slack for activity 2, 6 day slacks for activity 4, and 2 day slacks for activity 5. We can see here this is the number of resources for each activity placed here. Okay. Now, if you look through period 2 and 3, okay, so period 2 and 3, okay, so period 1 we don't have any problem. We have 2%. Let's say our resource constraint is that at any time, at any day, we can only use 3%. Okay. Okay. Let's say our resource constraint is that we can only use 3% each day, maximum 3% our resource available. So for activity 1, 2% is allocated will not be a problem. So we have to look at activity 2 and 3. We know that the number of percent allocated is 2 and 2. Okay, so it will become 4%, and this is more than the maximum resource available. So if we look into the slack, we have to choose the minimum slack first. So of course we choose activity 3 for 4 days because it doesn't have any slack. It's on a critical path. And using a heuristic method, a rules of thumb, the minimum number of slack is chosen. So activity 3 will start on end of day 2. Okay, we'll start on end of day 2. We'll run for 4 days. Okay, we'll finish at end of day 6. Because we cannot start with activity 2, we still have a backup of 1%. So we will start our activity 4, even though it has number of slack 6, just to utilize the number of percent allocated as the resources, maximum number of percent, because it requires only 1%. So 1 and 1, they can run concurrently. Okay, so now we have a maximum of 3, 3, 2, and 2. Okay, for day 3, 4, 5, and 6. Okay, so because we delayed 1 day already, the slack will become only 1 day slack. Okay, and the earliest start will start only the earliest after day 3. Okay, so we slash day 2, we write 3 here. So can we start on day 3? Okay, sorry, can we start at the end of day 3, which is on day 4 for number 2? Okay, now we look into the next page. We still cannot start our activity 2 on day 3, at the end of day 3 or 4 or 5 or 6, because the number of person used is 2%. If we put 2 here, it will become 5 here, which is already maximum. If we put 2 here, it will become 4%, which is exceeded the maximum resources. So at any day from day 3 to day 6 also, we cannot run activity 2. Means that activity 2 is delayed by 4 days. Okay, it can only start, the earliest is at the end of day 6. So that's why the earliest is at the end of day 6. If you see the slash number here, it increased to day 6. It start at the end of day 2. Plan to start at the end of day 2, which is day 3. Okay, when we delay, it becomes day 4, day 5, and day 6. Okay, it starts at day 6. Because it takes 2 days, it will finish at day 12. So the latest finish for activity 2 is day 12. Okay, hold on, yeah. Okay, so it finished at day 12. Okay, if you remember, activity 7, we'll go back here, yeah. Activity 7 can only start when all other activities are finished. So because of that, because we delay activity 2 by 2 days, okay, whereby it finished at day 12, 1, 2, 3, 4, 5, 6, and finish at day 12, activity 7 can only start at day 12 because it takes 2 days, day 12, at the end of day 12, which is day 13 and day 14. So it will finish at day 14 here. So the latest finish will become day 14. The earliest start is at the end of day 12. Okay, so because it's delayed by 2 days, the slack becomes minus 2. Okay, originally it doesn't have any delay, it doesn't have any slack. So we delay by 2 days, it reduces by 2. Okay, so we've done through period 5 and 6. Okay, so we will choose activity 2 to be done also because now the slack is minus 2. Okay. Okay. By using the heuristic methods, we will choose the minimum slack first. So the minimum slack here now is the activity 2, which is minus 2. Okay, minus 2. Activity 7, even though it's minus 2, it cannot be started until every activity is finished. So even though 5 and 6 is 0, we still cannot choose them because activities 2 is minus 2. So less than 0. So we put 2% here. Okay, 2% here. And then we choose activity 6. Okay, why we choose activity 6? Yes, is why. Okay, activity 2 is minus 2. Activity 6 is 0 slack. Activity 5 is slack 2. So we choose activity 6. Okay, after activity 2. Okay, so 2 for 6 days, 2% for 6 days, and activity 6, 4% for 4 days. Okay, it's still we didn't exceed the limit of the number of resources. It's still 3%. So means that we cannot add any more percent on top of these activities. Cannot add any more activities. So activity 5 will be delayed by 4 days. Hence the number of slash here. Okay, it starts with 2 slack because it's delayed by 4 days, it will become minus 2 slack here. Okay, so the earliest start is at the end of day 10 and the earliest finish is at the end of day 12. So it's okay. There's no more extension on the date. Okay, and the day number of days. Activity 7 can be started on day at the end of day 12. Okay, so with this, we can total the resources, number of resources that we have here. Okay, and we can see that we still have some slack for activity 4 because only 2% is here. Have extra 1%. Okay, so we can move here and there for the slack. But the critical path is also different now. Okay, Number 1, number 2, number 3, number 5, 6, 7 has become the critical events, critical path. Okay, they cannot be delayed by 1 day. If they're delayed 1 day, the number of the end date of the project will be delayed more than 14 days. Whereas number 4 still can be delayed by 2 days and the project still can be finished by day 14. Okay, so we see here the critical path here. Okay, so 0 slacks. Okay, no more extra slacks. Okay, okay. So -2, -2, -2 at the slacks means that we add extra 2 days. We extend the project by two days. Okay. So if we consider the extension of 14 days as the latest finish, okay, means that every event with 0 slacks is the critical event. So you see we have a new resource schedule network because we allocating resources for different dates. So what are the impact of resource constraint schedule? The impact of resource constraint schedules are as laid down here. Okay. We reduces the slack, reduces the flexibility by using the original slack. Okay. Increases the number of critical and near critical activities. So when we have a constraint in resources, we are actually have less flexibility over our project. We might be having minimum slacks and more number of critical activities, which is cannot be played around. Okay, and the scheduling will become more complex. Okay, so those are we already done our time constraint scheduling and resource constraint scheduling. Now let us have a look at the splitting activities. Another technique to actually manage our resource constraint or time constraint, which is by splitting the activities. By splitting the activities, there are a few disadvantages and advantages. So what are splitting activities? Splitting tasks or activities is a technique used to have a better project schedule or to increase resource utilization. Splitting can be useful too if the work involved does not include large setup or shutdown costs. Okay, setup means that when we end or split the activities, you have to start back the activities. When you split the activities means that you have to end the activities, which is the shutdown. When you want to start back the activities, is what we call a startup cost. Okay. Large startup and shutdown cost ni is when we look into the moving equipment from one location and to another, and this will involve a large startup and shutdown. Okay. Splitting is a major reason why projects fail to meet schedule. Okay, of course, because we start and end at different time. This is how splitting activities look like. For example, we have a big activity here. So we split it into activity A, B, and C. Because we split the activity into different activities, we will have a shutdown duration and a startup duration for each of the splitting. So this shutdown and startup will involve cost and will involve time. Okay. These are some of the benefit of scheduling resources. Okay. Leaves time for consideration of reasonable activities, cost time trade-off, change of priority. If the schedule delay is unacceptable or the risk of being delayed too high, the assumption of being resources constrained can be reassess. Okay, means that this is what we call a time constraint, cannot delay. Okay, then we need to assess the resources. Okay, so why resources scheduling tie to project priority? So this is some of the activities that you can do. Okay, so I won't ask you to do this at the moment. So what is the task of the project manager? Is to match, okay, the requirements and qualification and experience of the resources of your people to balance up the task and performance with the needed activities. Okay, we are there is tendency for us to assign uh, best people to the most difficult task, but it's not necessary. We need tendency to assign the most hardworking people to the most task, but it's not necessarily the best. We need to assign the skilled people according to their activities. Okay, so how do we manage multi-project resources schedules? If we have multi-project, how do we manage it? These are some of the multi-project schedule problems. Okay, overall project slippage means that some of the project really relies on each other. If delays on one project, will be delay on other projects. Okay, inefficient resource application. Okay, so the peaks and valleys of resource demand create scheduling problems and delays for projects. Let's say you have a limited number of resources that you need to allocate to multiple projects, a number of projects. So because some of the project have sometimes high number of resources needed, some of the project sometimes have low number of resources needed. So that means the peaks and valleys of resources. This will create problems. This will hinder your scheduling process. Okay, resource bottleneck, shortage of critical resource required for multiple projects at the same time. Bottlenecks means at the same times, and this will cause delays and schedule extension. Okay, so these are some of the problems when we deal with multiple project scheduling. So how do we manage multiple project scheduling? We create project offices or departments. So we make a smaller departments to handle each of the project. Okay, as a project manager, we create small departments. And then use a priority queuing system, which is first come, first serve, first serve resources. Okay, centralized project management. We treat all projects as part of mega projects, so they will become more prioritized. Okay, or if we have extra budget, we can outsource the projects to reduce the number of projects handled by our internal resources. Okay, I would need you to do this part of the activities. Okay, it will be contributed to your 10% quiz and assignments. Okay, imagine if that you are a project manager. What is the reason a project manager need to schedule the resources? Submit your answer in the not in the forum. You can submit your answer to my email. Okay, reason for scheduling resources from project manager perspective. Okay, you can submit because we are doing our online learning. You can submit this by tomorrow. Okay. Okay, guys. So there's sometimes we need to reduce the duration of the project. This is what we call crashing the time of the project. Okay, so why there is a need to reduce project duration? So one is time to market. So this is a competition view for reducing project duration. Okay, so we need to catch up with our competition to speed up our product to be marketed. Okay, for example, the electronic industry. So advancement in technology is very fast. So project duration also need to be reduced to meet the market needed. Okay, to whatever market needed. The second one is adaptability. Okay, not only on innovation but also adaptability for new challenges. For example, ESO has become a patron rebranding. Okay, so we need to reduce the project durations as a buffer for some of the unforeseen delays. There might be some of unforeseen delays happens. Okay, for example, the breakdown of equipment or weather hindering in weathers. Another reason for reducing project duration is the incentive contracts. Okay, so for example, earlier completion will give more benefit to owner and contractor, will give more bonus to the staff. Number five is why we reduce the project duration is because of the imposed deadlines. Normally, this is by the maybe the politicians or publics by the lawmakers. Okay, so accelerating project completion. There's two major conditions for crashing specific project activities. Crashing means that reducing the time to finish the project. Okay, so when resource are not constraints, we're going to be very happy to finish our project earlier than the time given. But when resources are constrained, then here we have a few options in order to accelerate our project completion. Okay, these are the things that we need to look into. Okay, so when resources are not constrained, then we can have there'll be no problem in adding resources. Okay, this is the most common method, okay, to reduce our time. Okay, because more people doing less job and will reduce the time for our project. Okay, outsourcing project work means that we have no budget constraint, so we can hire other people to do the project work concurrently in parallel to our current project. This is what we call subcontract and activities. Okay, scheduling overtime. Because resources are not a constraint, we can pay overtime to our team workers, okay, team members. Or we can establish a core project team, assigning professionals full-time to a project to avoid the hidden costs of multitasking in which people are forced to juggle the demands of multiple projects. Because we can assign one people, we have the money, we have the budget to assign one people to one task. So we can establish a proper core project which they only allocate their time to that project. This will minimize the time needed to finish a project. Okay, but when the resources are constrained, this is where the problem comes. So what we can do is do it twice, fast and correctly. Means that we build first and we build in a hurry without proper planning, maybe, and then if it's wrong, we do it again. That what it said, do it twice. Okay, it's just the second one is fast tracking. To rearrange the logic of the project network so that critical activities are done concurrently rather than sequentially. Okay, critical chain project management to accelerate project completion. Okay, we adopt reducing project scope. Okay, we minimize some of the project scope. We can also compromise the quality, which is not normally acceptable. Okay, but sometimes it's being done if we wanted it to be done in short time with constraint, with resource constraint. This is what happened. Okay, so let us look at the project cost duration graph. So when looking at the project cost duration graph, why we look at the project cost duration graph? This is some of the trade-off of the duration to finish up the project and also the cost incurred in the project. Okay, there'll be a trade-off of cost and duration whereby the project manager have to look into to find the optimized cost duration for the project so that we don't go so low on the duration whereby we increase so high of the cost, or we don't go so low on the cost whereby we increase the duration of the time to finish the project. So there will be a project cost duration graph as a reference. Okay. So in each of every project will have a direct cost and also indirect cost. Total of direct, when we plus the indirect and direct cost, this will become a total cost of the project. So you can see here, there'll be optimum cost time point whereby you will have a minimum total of cost. So this will be a optimum cost and also optimum project duration. Okay. So the indirect cost, where is the indirect cost? So the indirect cost actually will reduce every time you reduce the project duration. However, the direct cost will increase whenever you reduce the project duration. So there'll be a trade-off and you will need to find the optimum cost time point where you have the optimum total cost. With the information, managers can quickly judge and make decision when is the proper time to market that line, which is the project duration. So what are the indirect costs and direct costs? Indirect costs represent the overhead costs such as supervision, administration, consultants, and interest. Whereas the direct costs represent labor, materials, equipment, sometimes subcontractors if you subcon your project. Okay. In project indirect cost, it cannot be associated with any particular work package or activity. So that's why it is indirect. It is not verified or stated earlier of the project. Sometimes it will come in the middle of the project. So any reduction of time should result in reduction of indirect costs. Okay, wherever direct cost is normally stated at the beginning of the project. Okay, and it is directly assigned to the work package. So if the work is increased, the cost will be increased. The time is increased, the cost will be increased. Okay, project indirect cost. If the daily cost of supervision and administration and consultants 2000, any reduction in project duration would represent saving of 2000 per day. So these are the why indirect costs are significant when reducing the project duration. Whereas the project direct cost, salary of the supervisor for monthly. Okay, we stated already. Okay, so increase the project duration will increase the, so it's a fixed direct fixed cost incurred on the building. So there are three major steps required to construct a project cost duration graph. First, find the total direct cost for selected project duration. Then, find the total direct cost for the duration. Then find the total indirect cost for the duration, and then sum them, sum the direct and indirect cost, and then find the optimum cost point, time point, whereby that is the optimum project duration. Okay. Now let us look at how to determine the activities to shorten. So what is the difficult task in constructing cost duration graph? So the difficult task in order to construct cost duration graph is to find the total direct cost for specific project durations over a relevant range. Okay. So what is the central concern is to decide which activities to shorten and how far to carry the shortening process. Okay. Which activities to shorten. So normally what do manager do? We need to look for critical activities that can be shortened with the smallest increase in cost per unit time. Okay, so how do we select the critical activities? It depends on identifying the activities normal and crash time and corresponding costs. So this is the normal time and crash time and also the corresponding crash cost. So what is the normal time? The normal time represents the low cost, realistic, efficient methods for completing the activity under normal condition, whereby the crash time is the shortening an activity, the crash time is the time to shorten, time taken with a shortened activities. Okay.